Okay, so now we should have this sort of attached in our notebook, right, where we can put some information of what each number set is underneath the tab. Okay, so we're going to look at first. So these are number sets. So if you want a label for this, these are our number sets. It's how we group and classify numbers. You do not need to go home and memorize these all, but instead we need to be able to, if we heard the word, we would know what someone is talking about. Right? If I said list real numbers, you would go, oh yeah, I know what types of numbers those could be. So the first group of numbers that we have on our paper are our natural numbers. Okay, so on the top, when we look at our natural numbers, we want to flip open this flap. And underneath natural numbers, we are going to put that it is our basic counting numbers. Okay, before this meant hashtag, this actually meant numbers. You'll write it right. So you'll lift up natural numbers and you'll write it underneath that flap. And our basic counting numbers are anything that we could count by counting objects. 1, 2, 3, 4, 5, right? Anything that I could count an object is our natural numbers. Let's not write this down.
Sorry.
You don't even have it attached to your book yet. Let's go get some. You're behind. You don't even have a cut. You have to cut on the dashed line. Okay, so when you were in kindergarten, before you started school, right, your parents handed you a block and you went, ooh, 1 block. And they handed you a number and they went, ooh, 2 blocks. And then you got a little bit older and then your parents said, uh-oh, you have nothing. Now you have no blocks. And what number did you learn about?
0.
0. So our next number set, this is important to understand, is not a new set of numbers. Once the number is in, the number stays in. So all of these numbers still count. So it's all of these numbers, and we are adding 0. So we now have 0. 1, 2, 3. Which means that 1 is a natural number, but 1 is also a whole number. It counts in both categories. See? If you use a pass in your folder. Don't you get up? Yep. Our next ones are then integers. Okay, so now we're going to take all of the numbers we had before, and your teacher's going to say, okay, but what happens if you have 1 pizza and you want to share it with 4 friends? Right, and then you get that circle with all the pie pieces in it, and what do you start talking about? What do you do when you do that whole pizza pie thing? We know? Yep. Now we're going to add fractions? No, not fractions. We're not there yet. I'm crazy. I was jumping ahead. We're doing negatives here. We're not quite to fractions. This is when your teacher says, what happens if you have $5, but you owe $7? I was ahead of the game today. So now we can count in both directions. Then your pizza comes into play. And here's where we add fractions and decimals. Now, this one we have to give a little bit more rules to. Any fraction is fine. So it can be any fraction. Okay, but for decimals, it has to be something that is either repeating. Okay, this bar right here tells us that it repeats, so it would be 2.3737373737 for forever. Or a decimal that's what we call terminating. It ends. It just stops. Now, I either want you to, on this next one, draw a solid line of some type, or you can take a marker if you want to use a color. Put some in different places in the room. If you want to use a marker, you can grab a marker. Okay, but we want to draw a solid line across here.
Does it have to be a marker?
No. You can do it in pencil, you can do it in pen, you can just draw one in there. It's up to you. Notice how the wording for irrational looks different. Right? See how that's a different font? It looks different because it is different. Irrational numbers are all by themselves. We are not adding here. These are a separate group all by themselves. Okay, so this group, which are called irrationals, this includes our odd numbers. So things like pi, numbers with this dot, 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 which means that it goes on for forever. Do you know how many digits pi has? Do we know? There has been a computer at NASA that has been calculating digits of pi's 24 hours a day for the last like 30 years. And it has never found an ending point. It has never found a repeating pattern. It has never found anything. It just keeps going. Weird, right? It is a weird number. Okay, this also includes non-perfect square roots. And here's what I'm going to say so you have an example of this. The square root of 37. So if I take my calculator and I type in the square root of 37, I get 6.08276253. Weird number. That is irrational. The square root of 25 is not irrational, because what is the square root of 25? 5. Right? This equals 5, which means this goes up here. Our last category is real. Do you not feel well? Do you know where the nurse's office is? Yeah. Okay, are we okay on all of these? Then, in the extra space that you have either around it or above and below it, we're just going to put a couple examples to make sure that we're okay. So if I say the number 14, and we want to decide what number set it belongs to, we're going to find the first place that it appears in the list. Okay, so is 14 a basic counting number?
Yeah.
Yes. Okay, so 14 is a natural number. Once you know what it is, you can count everything below it. So if it's the first one, then it's also going to be, right? So you see natural here, 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 and here. So we're going to write down all the other ones that have natural in it. So it's a whole, it's an integer, it's a rational, and it's a real. Right? Because we have natural, 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 natural. So if I say negative 2/3, yes?
Rational?
It is rational because it is a fraction. So we would say rational, and then any place else that we see rational show up, which also shows up in the real. Okay. Here is what we are going to do for the rest of class.